Thank you for coming to the most technical panel of our conference here at the Wharton School of Business. I'm Eric Marks, one of the Penn Blockchain Club co-presidents and an engineering student here at Penn. And this panel is titled Scaling and Engineering because, of course, one of the hottest and contentious topics is how do we increase blockchain adoption and how we, on the engineering side, solve that problem with respect to scaling is an important or critical factor in how we accomplish that. And so on our panel today, we have our moderator, Dr. Brett Falk, who is a research assistant professor in computer science at Penn. Brett's research uses tools from mathematics and computer science to address large-scale societal goals in the areas of privacy and security in digital environments, facilitating transparency and trust. Brett has worked extensively designing and implementing protocols for secure multi-party computation, and his research has been funded by the NSF, DARPA, IARPA, the Office of Naval Research, the Army Research Lab, the National Institute of Health, and the Laura and John Arnold Foundation. To Brett's right, we have Arthur Breitman, who, before founding Tezos, worked as a quantitative analyst at Goldman Sachs in Morgan Stanley. Already in 2014, he quietly began working on the cryptocurrency network we now know as Tezos, whose most salient feature, perhaps, is its explicit mechanism to let cone holders vote on protocol upgrades. And then we have Lane Rettig, whose introduction who you'll already be familiar with, a core developer on the EWASM team at the Ethereum Foundation, and of course very active in the Ethereum governance and project management space. Finally, we have Patrick Neilson, a fellow Scandinavian, and currently at Clovyr with Amber Balde. He led JP Morgan's open source blockchain projects, including Quorum and Constellation, and sat on the firm-wide cryptography review board. A software and a security researcher by training, he's held executive positions in information security and privacy at a variety of large and small companies. An early contributor to open source projects including the Go programming language, Patrick is also a founding board member of the Securing Smart Cities Initiative and was a visiting researcher at Cornell University. And with that, I'll hand it over to Brett.
Hi, thanks. So I thought maybe we'd just get started talking a little bit about the projects that you guys are working on. Can we start on this end? I'd love to hear a little bit about Clovyr and sort of what your goals are and sort of what are the technical challenges that you folks on can kind of go through. And
Sure. So yeah, I'm Patrick Neilson and I work at Clovyr, and what we set out to do is to try to make this cornucopia of things that lives behind the hype of blockchain and decentralized technology, but is actually 30 to 40 years of research and engineering that nobody really usable. And so we're building tools that we'll be releasing quite soon that help people run these things. And by these things, I mean Ethereum and a few other kind of, shall we say, blockchain technologies, but also stacks that actually don't require consensus. And yeah, so one of the problems we have is we need to design something for people who are not overly technical, but it needs to still be something that lives up to the tenets of blockchain. Namely, we can't have a centralized point that makes everything easier. And there's quite a lot of upkeep in running a node by yourself. And so a lot of the stuff we've been working on is just making a system for self-healing, self-upgrading, and revertible node that even somebody without technical experience can use.
when you say not technical experience, you're still aimed at developers.
So the first stage is yeah, I mean it's kind of hobbyist developer is the audience. The UX for it is there literally is a UI, and you could use the whole thing through a UI, and obviously you need to do something with the node. That could be develop an application, or it could be using something that requires access to a node like MetaMask. What we're working on that will come a little bit later is developer tools and libraries for turning these kinds of abstractions into something where you can actually understand why it solves a problem and then do it.
Hey guys, I'm Lane. I am an Ethereum core developer, part of a team and an initiative known as EWASM. So EWASM stands for Ethereum Flavored WebAssembly. WebAssembly is a new and very exciting and very powerful standard that's emerged not from Ethereum, not from blockchain, but from the World Wide Web Consortium. So kind of companies you actually have heard of, like the Googles and the Firefoxes and the Apples of the world. And it's sort of this idealized virtual machine, which allows us to reason about and measure and move around computation in a very powerful, abstract way. I think that concept, purely from a computer science perspective, is very powerful and very, we've only just begun to realize kind of like what sort of doors that opens technologically. And so what we're doing with EWASM is we're taking this WebAssembly project and we are tweaking it in various ways to be able to use it as the execution engine for smart contracts in future Ethereum, right? So that means both Ethereum 2, Serenity, as well as hopefully in the existing Ethereum as part of this initiative called Ethereum 1x. And we get some really nice properties with that, right? One is just broader compatibility with other blockchains, but also with non-blockchain platforms like we were talking about what Cloudflare is doing. I think a lot of cloud services will begin moving in the direction of WASM. It gives us really great developer tooling, right? Because it's part of an existing set of tools. It plugs into existing developer tooling like debuggers, compilers, analyzers, static analysis, et cetera, that's existed for decades. Really high quality tooling. And it'll allow you to write smart contracts in a lot of other languages besides Solidity.
So can you elaborate a little bit more on you said some interoperability with these other things. So can you give like a concrete example of how this facilitates that? If we're not familiar with WASMs.
Yeah, so the question was about interoperability and like what that might look like. We're very much still figuring this out. It's very early days. But what I can say is like Firefox, very exciting. They announced, they're investing very heavily in WASM. WASM already exists in all the major web browsers. And they released a standard about 10 days ago called WASI, which stands for, I believe it's WebAssembly System Interface. And it's a lot like Node.js for JavaScript, right? It will allow you to, WASM was designed to run inside a web browser. But now we are in this world, obviously with Ethereum, we're not running it inside web browsers, we're running it inside Ethereum nodes. So WASI is a standard.
Web3 browsers.
Web3 browsers, yeah, that too. So WASI is a standard that allows you to like use WASM and like write a WASM program once, and it gives you hooks so you can do things like manipulating files and things, exactly like Node.js is to JavaScript, right? So what we want to develop is something called WABI. I mean, I'm just making this name up, but it's like the WebAssembly blockchain interface. And so we're working very closely with projects like Polkadot and Space Mesh. There are other projects as well like EOS and Tron that are using WASM as well. So it's really emerging quickly as a standard. And I envision a world where you could compile a smart contract to WASM and move it between chains.
Yeah. So, but it would be then focused in terms of interoperability, making smart contracts that were sort of compatible across chains. But yeah, so it would be a smart contracting language that would allow interoperability between smart contracts and that.
Right, so it's not a language, it's a VM, right? Okay. It's a virtual machine. So the idea is you can use, I mean, already today, a dozen languages, and in the future, it will be many dozens of languages. You can target WASM rather than like, bytecode for a particular platform or architecture. So it almost becomes like blockchain becomes its own architecture to the extent that we align ourselves with WASM. It's very exciting. You really have to zoom out and like just change the way you think about computing to really get how WASM fits in.
All right, can you help us do that a little bit more?
Sure. Why don't we hear Arthur's introduction too? Yeah.
Can you tell us just a little bit about Tezos, sort of where you are and what your plans are? This is from this topic of engineering and scaling.
Yeah, sure. So first of all, I only speak by myself. I'm part of this project. Obviously, I had an important role very early on. But so the main idea, I would say, of the Tezos project is to say, look, we have a large space of blockchain. There's a lot of innovation. There's a lot of new blockchains which are being launched. And one way to look at this is to say, oh my God, there's all these blockchains who are being launched, and we need to let them talk to each other and interoperate. And that's point of view. That's one point of view I think that comes from thinking about the web. I think that fundamentally, what people are trying to do with this blockchain is something that's different. You're not trying to represent information. You're trying to represent value. And since you're trying to represent value, there are strong benefits in integrating everything onto a single platform. And as a result, you have a dilemma, which is if you're going to have a single platform, how is it going to be able to innovate? How is it going to be able to disrupt itself and change without necessarily being outcompeted by other services? And the approach to that Tezos is taking is to say essentially what we want to do is instead of having people who have a great idea for launching a blockchain, maybe they have a new idea for a VM environment for smart contract like EWASM, or maybe they want to change the consensus algorithm. Today, the way this is done is you launch a new blockchain and you hope you're going to become money. And I think that at some point down the line that becomes more and more unrealistic. So what I'm hoping for is that innovators who have all these clever ideas for new cryptographic primitives, new way of doing smart contract, new way of doing consensus, can contribute to the Tezos ecosystem. And there are financial incentives which are built in the system so that if people can contribute and if people can make the system better, they can also benefit. So that's the main idea. And the way this takes form is in the form of governance. So essentially on the Tezos platform, what people can do is they can review proposals which are made for upgrading the platform, making it better, and vote on these proposals. So this changes the paradigm which has existed in blockchains, but in open source in general, of forking. The idea of fork-based governance is you have a project, an open source project, and someone has a different idea on how to take that project, and so they make a copy of the code and they take it in a different direction. And that works great when you're dealing with information because that can be duplicated costlessly. It doesn't work well with value because value cannot be duplicated like this. You can fork projects, but you cannot form community. You cannot fork Shelling Point that easily. And as a result of that, I believe, and that's I think one of the impetus of the Tezos project, that you really need to have this internal governance that lets you set a direction for the project and remain decentralized.
And so in terms of the overall goals of Tezos, do you imagine like an ecosystem of different sort of Tezos platforms that are all being guided differently, or sort of a more centralized mainnet that's being...
No, I would say it's neither.
Okay.
In a sense of like it is. You do not want to have a system that's centralized because that is basically going to be prone to attacks and systemic failure.
Okay.
So that's not something you want. But you also don't want to have the dilution of having many different initiatives. So you want all these initiatives to converge on a single platform, and that's what we're trying to do.
Okay. And so just for my curiosity, so then you have to have a governance structure that can support if one group wants to use the platform for one thing and another group wants to use the platform for another thing, that they can both kind of do that on the same platform and network? Yeah,
and that raises the question of what trade-offs exist when you design blockchain. And to mention something about Ethereum, if you put Ethereum in context around 2014, you have a lot of people who are all launching their own blockchain, and they're launching, golf coin. Yeah, you're going to use that coin to pay for your golf fees, and then all of these platforms. And the idea, or possibly one of the ideas of Ethereum at the time, is to say, look, you don't need to launch your own blockchain. That doesn't work. Let's all use the same blockchain so that you can benefit from the existence of each other. So if what you're trying to create is a ledger, what you need is a smart contract. You don't need to run your own chain. So that was one of the impetus, but that works as long as basically the existence of, as long as people don't have necessarily conflicting needs. If that happens, and especially if you have commons that you need to fund, like innovation, for example, then you do want to stick together. So the question is, do you have big trade-offs? Do you need do you need a special blockchain for healthcare applications because healthcare is so special? Do you need a special blockchain for golf because golf is so special? I don't believe so. I think in terms of design in this space, there are a few trade-offs that exist. I would say that there's clearly a trade-off between throughput and decentralization. That's one that's there and that's going to be here to stay. But beyond that, I don't think there's a whole lot of trade-off. In some sense, you can almost be everything to everyone.
Okay. Let me come back to Clovyr for a little bit about sort of blockchain adoption. So, right, your goal is to increase usability and to make it easy to to basically build tooling around this. How does Clovyr fit in relative to some of the other sort of like, tooling things around? So like Azure has a blockchain. I don't even know
Workbench,
exactly.
I think it's called.
Yeah,
Workbench.
thanks. Yeah, right, and right, IBM is pushing blockchain as a service, and so how does Clovyr sort of fit in relative to these kind of projects, right?
Yeah, so a lot of what I described that we're doing in the product that we're releasing not too long is very similar to some of the stuff that you get in these different cloud launchers. Azure Workbench, I think, is one of the more advanced ones. It just didn't let you actually configure things. The way that we're different is that we are not in any particular cloud. So it's more like a tool. If you're familiar with Terraform, it's kind of that, but for blockchain stacks. And you can target any kind of environment with it. And then the trick, the hard part for us is to design something where really all you need is that API key or what it is, and you will get an environment that will run a full node for a long time, even if you don't care about any of the details. And to your point about driving adoption, I mean, one of our main driving theses is that the vast majority of the world's developers do not use they don't care and they don't use any kind of blockchain technology. And I think a big part of why they don't care is that there's a huge gap you have to overcome to get into this space. And a lot of the people, many people who are in this space come either from kind of the enterprise side where they saw how some of these processes that their business is doing there's some aspect of it that could be disintermediated, or they come from like recently learned programming and is excited about this new paradigm and aren't, shall we say, burdened with the knowledge of wanting to use some methodology that they learned before. I think there's a huge portion of the world's developers that are not experimenting just because they don't want to spend 2 weeks learning something that is totally foreign to them and then being told basically you have to start from scratch. And there's no reason for that. And to Elaine's point, just something like WASM is talk about blockchain being a unifying technology. WASM sure is one too, because there really is a chance that all these tools can come together and work just the same if you're building something that actually benefits from decentralization, or if you're building Open Transport Tycoon I saw running in a browser the other day. That'd be really cool to have your save games on the blockchain. But yeah, just being able to get people on the same kind of stack, and I think WASM is a very positive development in that space.
If I may just add a quick thought, I couldn't agree more strongly with what you said. I think, like, I personally have a goal of getting, like, I mean, I know it's an arbitrary number, but I want to see like 1 million developers building, I want to be 1 million developers strong. I want to see 1 million developers building things on Ethereum in the not too distant future. And Solidity is great, Viper's great, EVM is great. It's gotten us this far, but I really think looking forward and looking both at the types of like developers in the world, I think I saw some number today, like 0.5% of the world's developers have touched blockchain at some point. So it's like we have a lot of work to do, right, to your point. There are a lot of developers who are comfortable with, JavaScript, the JavaScript stack. That's the most popular language in the world, or Python, or kind of the Microsoft .NET, suite. And one of the powerful things about WASM is that we get the ability to write code in like pretty much all of these languages. I think even like C# can target WASM. JavaScript, something like JavaScript, it's called AssemblyScript, can target WASM as well as also making use of all this amazing tooling that's been out there. I couldn't agree more. I think the tooling is a big thing.
Even Java, and Java was what was supposed to be. I mean, this is kind of a second chance
20 years
at
later,
doing
right?
what Java was supposed to do in the beginning,
Yeah.
which is to be this universal code that is machine agnostic. And I think that is the thing that a lot of people don't appreciate, just how big that is, that there's this coalition of people coming together to try this again, because that is what allows you to have the logic of the network live on the network itself and upgrade it, regardless if people are using, RISC CPUs or, whatever.
I would see this mostly as a cautionary tale in the sense of it's not clear to me why WASM is going to succeed where JVM didn't.
Well, there are no WASM applets. at the
There's
very
also
least.
not one company controlling it, right? That was the problem with Java, is that one company captured it, so to speak, whereas this has really been a global initiative via the W3C from the beginning.
No, I mean, but you're absolutely right. We're just kind of starting over, and if we don't learn from those cautionary tales, I think Java completely failed on the front end side. Like, I really mean that Java applets were totally useless, and WASM is not totally useless, but the UX was underwhelming to say the least. And WASM is already kind of past that by virtue of, being safely sandboxable, and the browser saying, okay, we will just run it.
Yep.
You can also do that with a JVM. I mean, I think it's mostly I would say it's mostly a matter of again building chilling point. If there was enough impetus behind JVM to somehow do this, there's nothing inherent to WASM or inherent to JVM as technologies that I think.
I disagree. I think one of the differences between the two is that JVM is a very high-level virtual machine, and it has the virtual machine. I mean, this gets very technical very quickly, but the virtual machine is very close to the language Java, and there are like opcodes involving really high-level constructs like arrays and things, or objects rather. Whereas WASM really is, and I'm not saying it's perfect, and maybe it won't work, right? But it is a platonic virtual machine, and it's both very general and very low level, and it's also very, very close to hardware. And so what that means is that actually translating from WASM, compiling to WASM, you get performance that's like 90% native performance. And I don't think that's possible with Java and JVM. The other thing is you can compile any language to WASM, which you can't do with JVM.
Okay. Yeah, but it's a good split. But we have LLVM, we have a lot of things for a while. So I'm cautiously optimistic, but
all right.
emphasis on cautious.
We can agree on that. This goes for all blockchain stuff, by the way, not just WASM.
Yes.
I like to think when we talk about in the blockchain realm, the shelling point becomes the shilling point, and there needs to be an ICO involved.
It's you who said that. I remember. That's a great line. Yeah.
Regarding the million developer, I mean, it's great to have a million developer, but I think one of the main problem is that currently we have more developers than users on a lot of the blockchains, and that's or at least we'll have more developers than users if we get to a million developers without first getting to millions and millions of users. I think that there are applications that we know have traction on blockchains and we know do work, and I think pushing those applications, making them better, making them more user friendly, and attracting more people to the platform and educating and seeing the value that the platform can bring is, I would say, should probably be a priority before we start building everything in an empty store.
Yeah, I mean, I absolutely agree with that, and I think a lot of developers using a thing is not necessarily always going to lead to good things. I mean, look at Linux. It was going to be the year of the Linux desktop for the last 25 years, and it was a decentralized thing where projects could fork each other and change things they weren't happy with. And that never really ended up happening. Although Linux does run on every other kind of device, but it did never reach users in a significant way. So,
well, but it did. They didn't realize it, but their phones run it, right?
Right.
And it is on a lot of devices. So
smartwatch, Chromebooks.
It runs more applications than any other operating system, but it's a bit more under the hood. Yeah.
And that may be true for, I think that will be true for blockchain as well, is that it's just going to be an implementation detail. And sometimes you'll talk about those benefits, but it's really equivalent to just, or not equivalent, but the benefits aren't the main driver of the thing, the user experience and the product that is built on it and the things that are possible because of the choices you made, but it's those things that are going to be appealing to people, not the fact that it's blockchain or there's a token involved. And in fact, I think tokens often are contradictory to the goals of the space.
We've reached consensus.
So back to WASM for a minute. So I understand the idea of basically being able to run a WASM machine on the Ethereum network. But what other sort of, outside of you've sort of alluded to other kind of benefits around this, like what, besides thinking about compiling, languages into WASM that could be run as smart contracts across different platforms? Like, what are the other benefits that we should be thinking about for this?
Yeah, I mean, honestly, it's one of those things, like it's always the case with new powerful technologies, like we just don't know what we don't know. And I think that it's one of those like paradigm shifts that like we just need time to let it play out. I think we can kind of survey the landscape and, like WASM runs in every web browser today, but we're not far from a world where WASM's also running in automobiles and satellites and coffee makers and toaster ovens and kind of like all the things, just like JavaScript runs on all those things right now. So if you kind of zoom out and look long term, like today we have very concrete conceptions. Like I have a program that runs here on my phone. I have a program that runs on a VM in Amazon, AWS. I have a program, a smart contract that runs on Ethereum, and each of those are very siloed right now. I think WASM is a tool that will allow us to start breaking down those walls, right? And we can do things like having, I think isomorphic is the word for this, like kind of applications that don't live as a single process on a single processor, in a single physical piece of hardware, or even on a VM. They kind of run in multiple places at the same time, right? And we've seen the beginnings of this with like isomorphic JavaScript applications, which run kind of partly on the back end, partly on the front end, and they can move data back and forth via AJAX. I can see a world where not only could you have an application running on one Ethereum shard, you could have one, a smart contract that runs across multiple shards, and then maybe you pan out and via a platform like Clovyr, a piece of it can be running on Polkadot, a piece of it can be running on some other, platform, and maybe a piece of it is not consensus critical, right, and is compute heavy, so that could be like a cryptographic code, like computing a ZK snark or something, and maybe that runs locally or that runs like on a cloud machine and gets checkpointed back to blockchain, back to Ethereum. The possibilities are kind of endless, but like I think WASM is the connective tissue between all these different platforms, potentially.
I would just add to that, I think it's funny that one of the other biggest trends of today is serverless, and everyone who's building serverless solutions is running your code on a bunch of their servers. And but what we're building is peer-to-peer technology is what could actually end up making it serverless, and that there is no dedicated server to run your thing. It's just running on people's machines. So it's kind of funny that it's all kind of coalescing in this way. And already, you mentioned Cloudflare. They recently announced Cloudflare Workers. That is a project kind of like Heroku, if you're familiar with that. You build your project, you have some source code, you push to Git, and it runs your application in the cloud, and you don't have to worry about anything. And there are some constraints about how you store data, so it scales well and stuff like this. But it's a very, once you do that work, it's very nice to have something that just runs and you don't have to think about it. And what Cloudflare did with Workers is say, we have this CDN that is running on thousands of servers all over the world. Why don't we just make these servers not just serve content, but also run arbitrary WASM and JavaScript? In Cloudflare case, it's JavaScript mostly, but others are doing it with WASM as well. And I think the difference here between Java and WASM is that Java kind of started with we're a server language, and then we'll add some sandboxing stuff. WASM was very much designed for browsers. The whole point is Firefox and Chrome should be able to run arbitrary things, and your files shouldn't get stolen. And I think that's made people a lot more comfortable doing these kinds of things, and it's exciting to see where that goes, because it could really be, you write your business or your business logic, and then a small portion of that is something that actually benefits from having consensus, and that goes
critical, exactly, yeah.
And that small piece goes on a blockchain somewhere, but everything else gets deployed to this network you don't really care about. It just is there, and people can view your application, and the entire developer experience is just that you have the source code and you push it somewhere.
It could all be WASM, like top to bottom.
Yep.
There's even a project which took this a step further. It's called Nebula, and it's not like a finished project, but check it out. The concept is really beautiful. It is a like WASM native operating system where it uses the sandboxing property so that you don't have to do so many system calls back and forth between ring 0 and ring 3 or whatever, and it just runs more efficiently. It's absolutely brilliant. So I think that WASM is going to like change the world of computing.
Another thing, I just find things very funny, I guess. I remember Gary Bernhardt did a talk in 2014 about the birth and death of JavaScript, and it was supposed to be satirical, but it's ended up being one of the most prophetic things in the space. He basically starts off by saying everything is JavaScript now, and as everybody knows, we can't live in the containment zone anymore that encapsulates all of Silicon Valley. We had some kind of nuclear war. But we're kind of in the post-native language world, and everything is JavaScript now. And because it's all JavaScript, we can just live in the kernel and escape the separation between ring 3 and ring 0 and get 20% performance increase, which offsets the decrease of running JavaScript.
Which is exactly what happened with WASM.
So this is happening now. That was a joke.
I'd like to present a slightly different view.
Be contrarian.
Yeah. So maybe WASM is going to be great for people deploying web application and serverless applications. People have had things like Docker or like AWS Lambda and all of this. You make a very good case for the fact that this is all going to replace that. And maybe we will see it adopted on blockchains as, if you're writing a smart contract platform, you basically need a VM. And I would say the main selling point of WASM as a VM is like, hey, you're gonna be a target for compilation that many people are going to support, but mostly Google, Facebook, and all these people are going to spend a lot of dollars making your VM faster, and that you don't have to spend those dollars yourself. So that's great. That being said, fundamentally, when you look at the design of a blockchain and what it is trying to achieve, why do you need to have global consensus among distributed peers? Why do you need to have people in many different jurisdictions all across the world verify this ledger many times, store copies of it everywhere in the world? And the reason you do something like this, which requires a lot of resources, which requires a lot of which slows you down in a sense a lot, is because you need very high assurance in your application. You need to have applications which are very hard to stop. There's this Ethereum expression, unstoppable applications, and I believe that's what is really the use case for blockchain. If no one is trying to stop your application, there's probably a better. You should probably put it on AWS and not on a blockchain. And so this is maybe more of a holistic viewpoint, but when I hear this engineering talk, that reminds me very much of what I could be hearing if I were on a Cloudflare AWS pitch. I'm saying that sounds great, but that sounds great for someone who would be a customer of AWS. And I think the applications we'll see on blockchains may be fundamentally different, and also may require a lot less computation than that. We're still here in a paradigm of let's run all these computations, but at the end of the day, the thing that a blockchain does is it transmits value from A to B. Right? You want to represent, what you're representing on a blockchain is value, it's not information. If you want to represent information, there are way better technologies, way faster than blockchains for doing so. And if you're transmitting values, the one thing that matters is what triggers this transfer of value? What is a trigger? And you end up with very simple business rules. And so in terms of design, the way that Tezos has approached the virtual machine problem. And again, so Tezos is an evolvable platform, and there are people within the ecosystem who are actually interested in adopting WASM in Tezos. It's a possibility. But at least in the initial design, the virtual machine for Tezos is a very high-level machine. It's statically typed. It is purely functional, and it has high-level operations. And the idea is yes, you lose a little bit in terms of overhead because your language is not going to be as generic necessarily, or as fast to be interpreted, but what you gain is you get a lot of readability and you get a lot of assurance in a contract that you write. So you're able to write contract that you can actually read. You can actually go inspect a contract on the blockchain and have a human readable contract and understand what it does. Now you can do that with a lower level VM, but the stack you need to do this is a lot bigger. You need to have certified compiler, deterministic compiler. You need to have an external storage for the sources. It gets a lot trickier. And so I think there's I do like I would call this a Web3 vision of blockchains as opposed to the internet money vision of blockchain. But I do worry that if we promote the view that blockchains are going to be the next substrate for the web, it's important to remember that there's going to be a lot of competition from centralized services who can, for most applications, provide very similar services at a lower cost.
So I don't want to put words in your mouth, but are you basically saying that the core parts of the blockchain are just so important that it makes sense to identify the things you need to do and then formally verify those? Because I definitely agree with that kind of principle. I'm actually surprised there's not more formal verification in the smart contract space, especially because it's tens of lines of code, not thousands.
Yeah. So the thing the rule of thumb I give is you look at the amount of money you stand to lose, and then you look at the number of line of code, and so that's why it started in aerospace formal verification, because the French had also rocket Ariane 5, and I think it was a billion euro, something like that, or maybe billion franc at the time. I don't know. And they just had a very simple overflow. So they had a counter, and the counter was supposed to hold a 32-bit number, but it was 16-bit. And they thought the rocket was accelerating this way, and it was accelerating the other way. And so it compensated wrong when the rocket crashed. And one thing you could do is you look at the amount of money, you look at the line of code, and you divide, and it gives you a budget per line of code. And so in typical smart contracts, you are looking sometimes at millions of dollars per line of code. So that's your budget for verification. And even though verification is expensive, it's going down a lot cheaper. And so there's a convergence between we now have more value that is stored per line of code than ever, and we also have better tools than ever to verify contracts.
There's definitely two schools of thought around sort of blockchain VM or deterministic VM design. I think Ethereum is definitely in the Turing complete camp, the big tent, let's have a general platform, and if you're to the extent that you're going to have those restrictions, we want them to exist at the language level and not at the VM level. So Viper is another language that you can use targeting EVM, and Viper is not Turing complete, for example. And in the opposite end of the spectrum, there are quite a few projects. I think Cadena is a good example of this, right? They've designed their own virtual machine, I think.
Bitcoin.
Yeah, okay, Bitcoin, you're right. Bitcoin's the extreme case, right? So it has a scripting language. It severely limits what you can do. It's not Turing complete, but it's much safer. So I just want to say two things. First is that different strokes for different blokes, right? There's going to be different. We need to let these experiments happen. I think there's different types of applications that will do well with one or the other type of platform. And I agree with your point that I think people haven't figured out, and we haven't really had this best practice emerge around just putting those consensus critical pieces of code on chain. It should be a smaller amount of code. It maybe doesn't need Turing completeness, and people tend to still just throw everything into Solidity. That needs to get better.
Yeah.
Yeah, and I don't think these points of view are fundamentally incompatible.
Right.
I'm personally very excited about compiling Haskell to WASM, for example. And of course, there's turtles all the way down. And at some point, Ken Thompson is going to come in the room and say nothing is safe because if you let anyone else contribute. But I think there's definitely room to have these small pieces that are really rock solid and aerospace grade, but still have people be able to use a common language that doesn't differ depending on who runs the code.
So one baby step that we're working on right now in Ethereum is rather than rolling out eWASM as a general purpose platform where any user can write any contract in eWASM and deploy it, because it's dangerous for the reasons you talked about, we may start with a set of things called precompiles in Ethereum, which is things like cryptographic primitives, hash functions, things like that would be too slow to run inside the EVM. And have that be trusted code that we, the core developers, write and audit as a baby step, but use that to get those WASM interpreters into Ethereum clients. So it can be done incrementally.
Mm-hmm. I look at so the other approach is also to try and Tezos does have a Turing complete smart contract language. And the main reason to have this as opposed to having a domain-specific language is that we don't exactly know yet what smart contracts people are going to write.
Exactly.
But I think that the way Ethereum did it, they did it for two reasons. One was we don't know yet what contract people want to write, and B was we want to be able to extend the protocol. So it's hard to change the Ethereum protocol, so people can build all sort of thing at the smart contract
At layer 2. Yeah.
In Tezos, it's a little bit different. We still have the ideas that yes, we don't know what we're going to do with this, but there's also the fact that, but if we do want to change things, we can do it at the protocol level. So one protocol change that I've seen proposed for Tezos or discussed was the idea of adding cryptographic primitives, like let people manipulate points on the elliptic curve directly as part of the smart contract language. And the downside is that you have to, you kind of have to do a protocol change. You have to implement it in your protocol, and then you roll it out, as opposed to say, "Hey, I'm just going to compile this." But the benefit is you don't have to worry. You're not going to have to worry about the overhead of your VM because it's just going to be directly executed by the machine.
Yeah, we're working on very similar stuff with eWASM. Cool to hear that.
so you mentioned a little bit about formal verification. So that's sort of a design goal. Tezos is how far along are you in that process? Is it?
Yeah, so just to clarify one thing, because there's sometimes misconception around that. Formal verification is not a feature, right? It's a process. You can formally verify anything. You can formally verify code on Bitcoin. You can formally verify code on Ethereum. You can formally verify code on Tezos, okay? Now, what the design of Tezos tries to do is to make that task, because it's not generally an easy task, is to make that task easier, both in the verification of the core protocol and in the verification of the smart contract. So the way the smart contracts are designed, for example, in Tezos, it's little things, but the smart contracts are purely functional, so they behave more like mathematical formulas, and it makes it easier to do proofs about them. Very small things. By default, if you create an integer in a smart contract in Tezos, it's an arbitrary precision integer, as opposed to being 32 bits or 8-bit integer. What's the cost of that? Well, if all you need is an 8-bit integer, and you're manipulating manipulating an infinite precision integer, you are losing a little bit of performance. Not a whole lot, a little bit. However, the benefit is you never have to worry about overflow bugs. It's just not going to happen to you. And that makes the analysis a lot easier, because we have good theorems for reasoning about integers. We don't have very good theorems for reasoning about 32-bit integers. I mean, they exist, but the mathematics of it is harder. So that simplifies things. Other thing, when you're doing smart contracts, instead of working like function calls, where I'm in a contract, I call another contract, and I call another contract, the contract in Tezos execute fully. And then at the very end, they tell you, okay, this is a new version of my storage, and this is the operations I want to do. You unqueue this operation, and then you do them. So for many designs, it works just the same as you would in Ethereum. For some design, it's going to be trickier and a little harder, but it also prevents a lot of things like reentrancy bugs, for example. So there's a lot of benefits you get out of this design. So small things. And likewise for the core protocol, the core protocol is written in OCaml. So the downside of OCaml is that it's a pretty obscure functional programming language. The upside is that there's a community of extremely strong, extremely talented OCaml developers. And OCaml essentially was built originally as a language in which to write the Cox theorem prover, which is the dominant theorem prover in the market. And so there's also a large overlap in the theorem proving community and the OCaml community. So just by virtue of affiliation, there are a lot of people who have background in this domain who are looking at Tezos and trying to do that. One more thing. Small things, but the smart contract language in Tezos, the VM, it's statically typed. You can actually use the type system of OCaml to prove that property. So even in a language which is not as advanced as a language with fully dependent types, where you could be able to make any type of proofs, in OCaml you can actually use the type system and leverage it to make very strong proofs. So we have proofs about parts of the code being independent and not being able to affect one another. We have proofs about language being typed and a few other things.
So when you say you have proofs, you've actually gone through the formal verification process for some parts of the...
We verify them with the OCaml type system. So if you trust the OCaml compiler, you have some proofs about it.
Should we open up for questions?
This question is for Patrick, but anyone can answer since you're a Haskell programmer. Can you comment on DAML, which was just recently opened up?
I think DAML is very exciting. I think it's great that they finally open sourced it. I'm personally excited to look at it and play with it.
Okay.
So DAML is the digital asset modeling language. And it's I would say even if you don't know Haskell or Camel or any of these languages with the S expression kind of syntax, it's very easy to understand. You say there's a person, they're this kind, and there's an organization, and they're this kind, and there's a few lines to talk about the actions that they can take. It's a very exciting language to be in an open space. I think it's a Apache 2 license too, which is especially for businesses, an important thing.
So actually, a follow-up on that, since you were at JP Morgan, can you speak about because it's kind of more from a political aspect, how willingly are institutions, especially the ones we're talking about, at adopting a new language into their stack?
New language. Well, part of Quorum was written in Haskell, and part of my experience at JP Morgan was just going through the internal process around using an exotic language, because Haskell isn't widely used. It's used in quant and different smaller groups inside many investment banks. It's OCaml, Jane Street, for example, and Haskell are both very popular, but they're not generally the kind of standard enterprise languages. I think they're very receptive as long as they understand the benefits. If it's just, this is weird and foreign, it's it's an uphill battle. But I think Arthur did a great job of explaining, for example, why you choose something like OCaml. Now in the smart contracting is also a new language, and I think corporates are still in the we'll hire some consultants to figure out what that means and maybe implement something for us, rather than having actual competence in different smart contracting languages internally. But that is changing, and I think that will change even further once the stuff we've talked about developers more broadly being able to use these things comes together.
Yeah. Last question.
Lane, a few days ago you put together a really interesting Twitter post on sort of Ethereum governance has failed. And I don't want to hold you to his words, because I know later you sort of said they were a little bit harsh. But I'd love for you to maybe elaborate a little bit, and maybe Arthur to get your views as well on Ethereum governance, given Tezos' completely different approach.
I'm worried if we open this box, this Pandora's box, we're gonna go way over time here. I guess my 60-second soundbite is and I did speak a little bit about it in my talk this morning. I think Ethereum's in a very critical place right now, and I mean that both there's a lot of opportunity before us as well as a lot of risk. And I think that I think Ethereum faces three existential crises right now. I think one of them is around adoption. The second is scaling, which we're supposed to talk about in this panel, but we didn't quite get to. And the third is governance. And actually, I think adoption and the scaling part are in pretty good hands and are moving well. But I think governance in Ethereum has become kind of stuck. It's a very complex, very multifaceted question. I look forward to there's no way I can possibly answer it now. Maybe grab me afterwards. We could talk more about it. I will be writing more about this, and I think that this conversation has begun and become more active, and more people are now recognizing that we need to be having this conversation, and now is the right time. So that's why I feel optimistic, and some of my later tweets were slightly more optimistic. I also think we have a great deal to learn from projects like Tezos and folks like you guys, because you have a very different approach to governance, and you're not running into the same problems we are for that reason.
Well, we're newer, so let's see down the line in a couple of years what happens. But I think the main difference is that Tezos has an on-chain mechanism for ratifying governance decision. It doesn't mean that the governance happens very differently necessarily, in the sense that I think that most of the if you're looking at Tezos, it doesn't try to make governance decisions on chain, right? The decisions are probably happening off chain, in discussions, in forum, in all sort of media, and then once there's some rough consensus around that, you can ratify this on chain, which is also why you can have very conservative threshold for adopting decisions. There's in Tezos, for example, you need a 80% supermajority to pass anything. So sometimes some people focus on some game theoretic attacks or vote buying or this type of stuff. But as long as the threshold are high enough, essentially what you're doing is saying, hey, we just want to have, it's almost, don't think of it as a decision, think of it as an on-chain oracle for the decision that has been made off-chain more than anything.
And funnily enough, that's actually not that different from what we want to do. I want to do not binding kind of voting or token holder voting, but more signaling, right? And still have the core developers be the final arbiters, which is not that different from what you're describing.
I think the binding part is important, the fact that it has teeth, because otherwise, you get apathy. Because if you're just voicing your opinion, but you're not sure it's going to happen and so on and so forth, it's different. It's a different feeling than voting and actually saying hey, I'm part of the state transition function here. Right. There's some value here, and there's a very practical concern, which is that if you want many people to run nodes, and not necessarily just block validators, but if you want people to be able to run full nodes and track the chain, you need a way to upgrade those nodes. Otherwise, you're going to be in a situation where so many people are running the old nodes that you're unable to enforce any type of decisions because there's too much inertia in the system. So the automatic upgrade part is, I think, an important part of the system.